Frequently, unfortunately, we will not know the population standard deviation. This introduces us to the t-distribution. So sometimes you may know or be able to guess what the population mean or average is, but not know or be able to guess the population standard deviation. Well, what happens then? How do we estimate that standard error? Well, we're going to do that by using some information we do know. Because the population standard deviation is unknown, we're going to use the sample standard deviation to estimate that sigma x bar as s divided by the square root of n. We use a different distribution. Instead of that normal distribution, it's called the t-distribution to find the p-value. The main difference between the regular z, or that normal distribution, the normal curve, and the t is that the z has thinner tails, the t has thicker tails. It has heavier, thicker tails than the normal distribution. As n gets larger and larger, though, this t-distribution looks more and more like the normal distribution. The heaviness of the tails is determined by the degrees of freedom. The degrees of freedom, and you're going to be talking more about this in Stat 252, is determined by taking the sample size and subtracting 1. The smaller the degrees of freedom, the heavier, in other words, thicker, these tails will be. Now, the standardized score, instead of a z-score, we're going to use a t-score. The t-score should look familiar to find. We take the x bar, so that sample average minus the population average, and divide it by the standard deviation. In this case, since we don't know the population, we need to use that population standard deviation. We need to use the sample standard deviation. T, just as a heads up, T is only used for quantitative data only. We do not use the T distribution for categorical data. So let's move on to an example. Looking at body temperatures. So the average body temperature of humans is thought to be 98.6, and we have data from a sample of 65 healthy males, and it turned out to be 98.105 and a standard deviation of 0.699. If the average body temperature of a healthy adult is 98.6, would it be unusual to see a sample average temperature of 98.105? And it says investigate. So the first thing I'd like you to do is I'd like you to pause the video and write down and label all the numbers, what you have, like what mu is, what n is, x bar, etc. And then come back and check to make sure you have everything. So please pause video and check your answer. You're going to notice that sigma is unknown here. We're not told what that population standard deviation is. It's not known. So we cannot use the z-score here. Instead, we're going to use the t. Okay. So how would I know that I could use t? Well, we're going to stick with the n greater than 40, and n is greater than 40 here. So to calculate the t, that t-score, we're going to take the 98.105, so our sample average, minus that population parameter, all over that standard error, 0.6, over the square root of n. And we get negative 5.71. You may be like, well, we haven't done t-tables yet. How would I know where that is or how extreme that is? Remember, the z and t look similar. If I told you it was more than 3 standard deviations away, hopefully you think back to the z and you're like, whoa, that's pretty far out. Remember when we looked at that empirical rule. So the same idea applies. The sample average was 5.71 standard deviations or standard errors below 98.6 degrees Fahrenheit. That's quite a bit lower. That's way out in that tail. So what would our conclusion be? Would it be usual to see something 5.71 standard errors away or standard deviations away? Or is 5.71 not bad? Once again, think back to that empirical rule. So in conclusion, it would be very unusual to be 5.71 standard deviations or standard errors below the average 98.6 degrees Fahrenheit. Does that mean that we can say it is actually that 98.6 is too high? No, this is just a small study of only 65 men, healthy men. We would need to do a lot more a lot more sampling, a lot more studies to actually change that the average body temperature as a whole. Remember, we use the T-score if we don't know that population standard deviation.